In the vast, silent reaches beyond the edge of our solar system, something remarkable is happening. A small spacecraft, no larger than a car, launched over 40 years ago, is still sending back messages across billions of kilometers. Voyager 1, a name that now feels almost poetic, was never designed to go this far, this long, or this deep into the unknown. Data. A cosmic postcard from the edge of forever. But recently, scientists noticed something odd. Among the expected readings and familiar cosmic patterns, Voyager 1 detected a strange signature, one that didn't make sense. Something no one predicted. Not empty space, not quite. But not normal either. A mysterious hum that seemed to fill the void. And this discovery could change how we understand everything, the structure of the universe, the nature of deep space, even the boundaries of physics itself. Voyager 1 began as a mission to study planets. But now, it's become something far more profound. A messenger. A pioneer. And possibly, a discoverer of cosmic secrets no one imagined. Its story didn't begin with glory. In fact, it almost never began at all. On September 5, 1977, Voyager 1 sat atop a Titan E rocket, waiting to launch. As the countdown reached 0, engines fired and the spacecraft began its journey. But in the final seconds of ascent, the rocket nearly ran out of fuel, it came dangerously close to failure. A single miscalculation, and Voyager would have plunged back toward Earth in a fireball. But the math held. Just barely. And Voyager 1 was born into the stars. Interestingly, it wasn't even the first to launch. Voyager 2 had already left Earth, just a few days earlier. But thanks to a faster trajectory and gravitational boosts, Voyager 1 quickly overtook its twin. This was possible because of a rare and perfectly timed planetary alignment, one that occurs only once every 176 years. Using a clever technique called a gravity assist, Voyager could slingshot from one planet to the next, gaining speed with each pass. Its first destination. Jupiter, the largest planet in our solar system, a gas giant with a gravitational pull so powerful it can capture comets. When Voyager 1 approached Jupiter in 1979, the world watched in awe. It sent back images that redefined what we thought we knew. No longer just a blurry ball in a telescope, Jupiter came alive, filled with roaring storms and swirling clouds. Voyager revealed the Great Red Spot in stunning detail, a storm larger than Earth, raging for centuries. Lightning danced through its clouds, and fast-moving jet streams shaped the atmosphere into bands of color and chaos. But the surprises didn't stop there. Voyager turned its gaze to Jupiter's moons. Among them, one stood out like nothing we'd ever seen. Io? This small world was no frozen rock, it was alive. It was the most volcanically active body in the solar system. Lava lakes bubbled, eruptions blasted into space, and its surface reshaped constantly by volcanic fury. Then came Europa. Smooth, white, and covered in cracks, like a shattered window made of ice. Voyager's photos showed strange, linear marks, hints of movement beneath the crust. And beneath that crust, scientists believe, is a vast, global ocean of liquid water. More water than all of Earth's oceans combined, locked beneath a sheet of ice, warmed by the tidal pull of Jupiter's gravity. Could there be life there? Microbes, alien creatures, something unexpected? Voyager had raised the question. Its journey continued. In 1980, it arrived at Saturn, the most visually stunning planet of them all. Its rings shimmered like delicate threads of the stunning rings of Saturn, so striking from afar, were not solid, as we once believed. Voyager showed us that these shimmering bands were actually made up of countless particles, ranging from dust-sized grains to massive ice chunks. They were shaped into distinct lanes, valleys, and gaps, sculpted by invisible forces that danced in the vastness of space. The complexity and beauty of Saturn's rings became a cosmic masterpiece, a puzzle only now being fully understood. These icy particles weren't just randomly scattered. They were influenced and guided by small, hidden moons, orbiting near the rings. These tiny moons, known as the shepherd moons, acted as cosmic sculptors, gently guiding and shaping the ring structure like invisible artists, quietly pulling and pushing the particles into carefully crafted formations. It was a revelation that added another layer of elegance to Saturn's already mysterious aura. But Voyager's mission wasn't just to observe the stunning planet. It turned its gaze toward one of its most intriguing moons, Titan. A world so massive it's larger than the planet Mercury, but entirely wrapped in a thick, yellow-orange haze that veiled its surface. Titan was unlike any other moon in our solar system. Voyager could not pierce through the shroud of fog, but the data it collected sparked a revolution in our thinking. Titan's atmosphere was unlike any other, a dense, nitrogen-rich environment with traces of methane. The composition of its atmosphere was eerily similar to what scientists believe Earth's early atmosphere may have been like, before life took hold and began transforming the planet. Titan was a frozen world in deep space, and yet, it held clues that could unlock the story of life's origins. Though the surface remained hidden, scientists speculated that beneath that thick fog, rivers and lakes of liquid methane might be carving out the land, creating an alien landscape in the distant reaches of the solar system. Titan, with its bizarre chemistry, could be a parallel to early Earth, a frozen world with the possibility of life, not in the form we know, but in a completely alien way. Could methane-based life exist there? Was Titan, in its own cold way, a world where life might be waiting to emerge? Voyager had opened a door to possibilities no one had dared to dream of. As Voyager prepared to leave the wonders of Saturn behind, it did something profoundly moving. It took one last, poignant image with its camera. A final glance at our home, from a distance no human eye had ever seen. Voyager turned its camera back toward Earth, and what it captured was breathtaking, a tiny, fragile speck of light, suspended in a beam of sunlight. The Earth, from that far-off vantage point, was just a pale blue dot, so small, so insignificant against the vast backdrop of the cosmos. That tiny dot represented everything we've ever known, every human being, every moment of joy, every war and conflict, every tear, every laugh, every fleeting dream, every thought ever shared. Carl Sagan, who had been instrumental in the mission, would later write about this image, calling Earth a mote of dust, suspended in a sunbeam, a humbling reminder of our fragility in the great expanse of the universe. It was a stark moment of reflection. We are, in the grand scheme of the cosmos, so small, yet so infinitely important to each other. After that image, Voyager's camera was shut down. Its primary mission had been completed, and its role was no longer about capturing images of planets or moons. The mission had evolved. Voyager was now in the business of venturing into the unknown, alone in the vastness of space, gathering data that might hold the key to understanding the deeper mysteries of the universe. By 2012, Voyager 1 had achieved something no other human-made object had ever accomplished. It crossed the boundary of our solar system. It passed through the heliopause, that invisible frontier where the sun's influence fades, and the harsh cold and radiation of interstellar space begins. Voyager had left behind the protection of the solar wind and entered the